Okay, hello everyone. I'm Lukman. I'm on behalf of Mr. Furqon and Mr. Yuniarto. I'm here to presentate one of the paper for about development and reliability-based decision-making for optimum operation and maintenance strategy in coal-fired power plant. It's from our companies. And this is the outline. The first one is introduction and literature review. The third one is methodology, result, and conclusion. 5 phase. The first one is introduction. The research background. The first one is recently electricity business challenge is how power plant can operate reliable and more efficiently. That's the best power plant as we know for now. The second one is operation and maintenance, or OM, costs only about 15% of all life cycle costs, and this figure may fluctuate to around 20%. And there's several options of power plant OM could be optimized. And then this DSS, or decision support system, is a very important tool to select appropriate OM methodology for maximizing our profit companies. The research aim, of course, to create a model of optimize several option OM strategies used in managing coal-fired power plant. Therefore, they can provide maximum benefits, indicates from net present value, or NPV, and reliability or availabilities, because that's how we see from the power plant. It's all about efficient, reliability, and availability. There's two aims. The first one is asset owner. It's to determine appropriate OM methodology will increase return of asset, or ROA, and return of equity, or ROE. Second one is to determine strategies. Therefore, its price remains competitive in the market so that our companies stay healthy in financial because they can still survive. And for the OM companies is to assist OM companies run their business remain efficient. This yields maximum profits. The research constraint, the first one is the model test by actual data from a 600 coal-fired power plant in Indonesia, like Python, 9 Python Ubejom in our companies. And second one is to analyze cost structure is related to operation and maintenance phase. The third one is equipment reliability within useful life period. And the fourth is research point of view as asset owner. That's how we see it. And we're going to literature review. There is power generation OM option. This is from Mercer, 2009. It's about evaluation of outsourcing decision of power plant station operation and maintenance service. And then from Kulkarni, Arkwal, Sis and Friends, 2013, is about outsourcing operation, a new trend among IPPs, or independent power producer. This is the previous study, is from the Mercer 2009. There's 5 options of OM outsourcing available due to its scope of work. And decision-making criteria are life cycle costs, reliability and availability, quality, management, health, safety, environment, performance, overhead, and transaction costs. And weakness is for reliability was the time independent. Decision-making was subjective due to expert competence. From Santamino 2014, the DSS, or decision support system, is about coal supply for power plant using system dynamics. That's about research object. It's Krabi coal power plant, a 800 megawatt power plant in Thailand. And the second one is to decide coal supply, whether they're from nearest mine or imported for coal from other countries. System dynamic is utilized for simultaneous coal supply with 30 years period, considering related exogenous factors, and objective function is to maximize the NPV, NCF, payback period, and IRR. This is from EPRI's power plant technical economical map. It's about cost analysis only for OM phase, for sure. Next one is methodology. This is the method. We're deciding about system dynamics from model, developing from power plan report or corporate document and etc. until we finding analysis model, of course, simulation, running simulation, verification, the results, and we're analyzing that until conclusion. This is the CLD or causal loop diagrams. This is about how our power plant produce energy from a very far away, like in every certain conditions. There is NPVs right here. There's net cash flow. It's maintenance project budget. There's thermal efficiency. Everything is connected from the finance, from the engineering, from how you efficiency of the power plant, from everything. It's connected from the machine, of course, and from the fuel to the price. And now we're talking about reliability and availability calculation. We're using Vensim. We got our data from our companies using Navitas, using a lot of resource of data, so that we found a constanta, and then we're using the failure rate, we're using probability density function, and of course for the availability is from mean time to failure equation. This is the model development in Vensim. There is 7 steps from study actual case until overall model testing. We're using Vensim. And then this is the structure model development. There's 2, reliability and availability model, then operation costs, and then maintenance cost model, cash flow model. We're seeing the result from there. This is the model verification from logical test, structure test, unit consistency until sensitivity analysis. We build the equation and then running the simulation after the result was taken. We keep doing some sensitivity analysis just to make sure if that we have in a correct loop of equation. We're just making sure of that. There's reinforced feedback loop and there's balancing feedback loop. This is about the finance and efficiency of the power plant. I mean, like if you give a certain equation in the energy that you use, there's an equation and there will be finance, like how much money you'll make or how much energy you will provide with the equation. This is the sensitivity analysis. There's NPV power plant, and then capacity factor, coal price, and SE duration. This third sensitivity is to make sure that the equation that you have been built is very good. And then we're seeing from the graphics right here, the year from the 2018 and 2027, there will be a gap between those graphic, so that and any equation that you give, any input, it will makes this equation make the result is keep changing, and that will makes our stakeholder give a very good decision about coal price, capacity factor, and SA duration. The parameter is OM contractor compense or series inspection, dispatch capacity factor, or coal price. We all know about this. This 3 point is very, very vital in our power plant companies. This is the model validation. You showing about mean absolute percentage error, just to make sure that our model is very valid and ready to use for the equation until making decision, of course. We're getting to conclusion. First, this research provide the DSS or decision support system to assist the power generation business to win the competition for sure. For power plant owners, this tool is useful for deciding appropriate OM strategies that result maximum availability and profit. For OM service companies, it's very useful to determine the correct strategy to provide competitive prices without neglecting the quality. So you already know if you make a certain decision, what's the result or the outcome will be. That's really helpful for the board of directors. The second one is variables are the most important sensitive to NPV so that they can take some necessary action before business risk occurred. It's known that coal price is the most sensitive variable, is the equal about 62%. As we're seeing in that here, the external factor is very, there will be causing a very deviation output in the outcome of this graphical. So it's very sensitive, of course, from that third point of equation. That's about our presentation. Thank you for listening and see you soon. Thank you.